So hello, everybody. Thank you all so much for attending and welcome to the opening keynote of the Los Alamos ScienceFest 2020, this great series of virtual events so that we can all keep our eyes on the future according to the theme. This particular event that we're at right now is co-hosted by the Pajarito Environmental Education Center in Los Alamos, which is probably everyone on this call knows is teaching the whole community of northern New Mexico about the region's many natural wonders. My name is Rachel Conrad, and I'm the Chief Communications Officer at Impossible Foods. I'm also, by the way, thrilled to be here in White Rock, New Mexico right now, which is one of my absolute favorite places in the whole world. It also happens to be home to my in-laws, so it's a great place to be. Okay, so let's start with a very fun fact here. I did some data crunching, and it turns out that Los Angeles County, California has the greatest number of total restaurants and grocery stores that serve the Impossible Burger. But interestingly enough, Los Alamos County, New Mexico probably has the greatest density of Impossible Burger serving locations per capita. So congrats to all of the very smart people here for making very smart choices. So speaking of that, you can actually try the Impossible Burger at several restaurants here in town. One is Surfy. I think he was the first in Los Alamos County to serve the Impossible Burger a couple of years ago, by the way. Pajarito Brew Pub and Grill, Cottonwood on the Greens, and you can also try the all-new Impossible Sausage, which debuted just last week at nearly all the Starbucks nationwide, including the one just up the hill here from White Rock in Los Alamos. And you can buy the raw 12-ounce package at Smith's, including White Rock and in Los Alamos when it's in stock. And if all else fails, you can buy it directly from impossiblefoods.com. We sell direct to consumers in larger quantities. So if you want 5 or 10 pounds of it, you can order and it's shipped right here like it was for me today. So without any further ado, I'm going to introduce you to your keynoter and my boss, Dr. Patrick O. Brown. Just a little bit of data about Pat. He got his bachelor's, MD, and PhD at the University of Chicago, and he also completed a residency in pediatrics. He studied at the University of California in San Francisco, where he helped define the mechanism by which HIV and other retroviruses incorporate their genes into the genomes of cells they infect. And after that, Pat became a professor of biochemistry at Stanford, where he developed the DNA microarray to monitor the activity of all the genes in a genome. He pioneered the first use of gene expression patterns to classify and improve prediction of their, to classify cancers and improve the prediction of their clinical course. He also co-founded the Public Library of Science, which is a nonprofit publisher. It makes scientific research freely available on the open internet to the public. He's a member of the National Academy of Sciences and the Institute of Medicine, and a recipient of the National Cancer Society Medal of Honor. And after all of this, award-winning career, Pat took a sabbatical back in 2009 from Stanford, and he used the time to reflect on how he could use his experience and his wisdom to make the largest positive impact on the whole planet. And he quickly realized that, forget about curing cancer or HIV. The most important thing that Pat could do would be to replace animals in the food chain, which is not something a lot of people might have thought back then. So in 2011, Pat, the scientist, quit his job at Stanford to become Pat, the CEO of a Silicon Valley startup called Impossible Foods. So without further delay, I want to introduce you to Pat so he can talk about why he made this crazy choice. And just a reminder, he's here after taking questions. So please submit them. We've already gotten several in advance, thank you. But please keep submitting them. Those that I and my colleague Esther can answer quickly by the chat, we will. And then otherwise we'll field them to Pat. So thanks, Pat, take it away.
Okay, thanks, Rachel. And thanks everyone for inviting me to be here virtually. I was really looking forward to my trip to Los Alamos. So one of the most bitter things about the COVID epidemic is that it nixed that trip, but next chance I get. Anyway, what I want to do with this talk is, it's not going to be at all comprehensive, but try to hit on a few points and try to provoke some questions so we can have a lively Q&A, and definitely hit me with your hardest questions. I don't be shy. So as Rachel said, 10 years ago, I was basically doing my dream job, the only job I could possibly imagine doing, and really I thought it was the best job in the world, as a professor at Stanford, where I had great colleagues and great students and postdocs and complete freedom to basically follow my curiosity, and my only sort of responsibilities were to discover and invent things and mentor really nice, smart students. About the last thing I ever imagined doing was going into business. I had zero interest in it, nothing against it, but just thought it was a completely boring way to make a living. And I had no particular interest in food. In fact, I'm probably in like the bottom 5 percentile of, in terms of level of interest in food, other than just putting it in my mouth and chewing on it. So then 10 years ago, I had a sabbatical, and basically, as Rachel said, I just use it to try to identify the most important problem in the world that I might be able to contribute to solving. And when I started doing the research on it, it quickly became evident what the answer was, and actually it was kind of embarrassing to me that I didn't already know it. And that is not just the most important problem that I could consider working on, but the most important problem in the world, the most urgent threat that humanity faces and our planet faces, is the catastrophic environmental impact of our use of animals in the food system. So, like I say, I was embarrassed not to realize this myself, and I think most people are unaware of it, but the use of animals to make food is by a wide margin the most destructive technology on Earth. And this was something that actually even 10 years ago, the UN Environmental Program recognized and remarked on, but it's only in the past few years that it's become pretty widely recognized by environmental scientists that this is problem number one for the global environment. And I could give you a long list of reasons why this is the most problematic technology on Earth, including food security, the extremely inefficient use of resources, which makes it a food security problem, public health, and on and on and on. But I'm just going to, and a whole bunch of environmental and resource use issues, but I'm just going to focus on the top two environmental consequences, and really the top two environmental problems in the world. Number one, and this is in no particular order, is the greenhouse gas impact. So I think more and more people recognize that animal farming is a huge net source of greenhouse gas emissions. Just to kind of give you a benchmark, greenhouse gas emissions from animal agriculture are 60% greater than the total greenhouse gas emissions that would be produced if every oil field in the Middle East were turned full on and lit on fire. It's more than, actually not twice, but more than 4 times the total greenhouse gas emissions from burning all the fossil fuel produced annually by Exxon, Shell, BP, and Chevron combined. Okay, so we usually think of those guys as pretty much the whole story in greenhouse gas emissions, but they're pipsqueaks compared to animal agriculture. The second, maybe even bigger environmental problem caused by this technology is a catastrophic collapse in global biodiversity. And as one metric of it, this is a chart from the World Wildlife Fund and the London Zoological Society and some academic institutions do a survey periodically, a deep census every 10 years of the total populations of about 10,000 different vertebrate species around the planet. And what they've reported in recent years is that there has been a complete collapse in their numbers. This is not extinction. This is population losses. On average, across mammals, birds, reptiles, amphibians, and fish, and pretty much across the board, the total populations are less than half what they were 45 years ago. Less than half what they were 45 years ago. In fact, 60% fewer wild vertebrates than 45 years ago. And the cause is almost entirely due to the use of animals in the food system. This is a complicated chart that Rachel asked me to leave out, so I apologize. But let me just say that the kind of teal sector represents exploitation, namely hunting and fishing, particularly fishing. Direct exploitation of fish populations is virtually the entire cause for their drop in numbers. And the pink and green sectors are habitat degradation and habitat loss. And that's almost entirely due to the use of animals in the food system for a reason that I'll get to in just a second. So this is just another kind of metric, and it starts to illustrate the problem. So 10,000 years ago, this was roughly the relative numbers of domesticated animals, humans, the relative biomass, I should say, of domesticated animals, humans, and wild vertebrates. The wild vertebrates vastly outweighed humans and domestic species. Okay, quick cut to 1979. By 1979, the cattle alone outweighed the human population and all wild vertebrates combined. And as you heard, that population of wild vertebrates since then has dropped by half. So the situation today is that the cattle alone living on Earth outweigh every remaining wild vertebrate, terrestrial vertebrate, by more than a factor of 10. Okay, and you can just check this against your own experience. I mean, when you're driving across the country, you're pretty much, anywhere just kind of randomly sampling the land mass, and you think about what animals do you immediately see. It's cows, 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 cows. Oh, a groundhog, cows, cows, cows. Oh, a squirrel, a pigeon, cows, more cows. They are by far, in biomass, the dominant species on our planet. And that comes at a consequence because there's only a finite amount of primary productivity to feed every living thing on Earth, okay? And this gives you an idea of how disproportionately that finite primary productivity means photosynthetic production of new biomass, how disproportionately it gets sucked up by cows. And this is just elaborating on that. So as I said, the farmed cattle alone outweigh every remaining wildland vertebrate by more than a factor of 10. Farmed pigs outweigh all remaining wildland vertebrates by more than 50%. Goats and sheep, same deal, outweigh all remaining wildland vertebrates by more than 25%. Farmed poultry outweigh all remaining wild birds by more than a factor of 2.5. Another way of looking at this is to think about meat consumption, because that's effectively indirectly human appropriation of primary productivity, to use the ecology term. The meat that we consume annually, the mass of that outweighs all remaining living wildland vertebrates by about 6-fold. Flip side of that, or just, a consequence of that is, often people will say, you know what, we'd be better off if we just went back to hunting animals for food, much more sustainable. Well, actually, no, absolutely not. If we went back to hunting wild animals to satisfy current meat demand, in 2 months, there wouldn't be so much as a squirrel or a chickadee left on Earth. Okay. The biggest reason, the biggest mechanism by which animal agriculture is devastating terrestrial biodiversity is this: it's land footprint. So today, the land footprint is 45% of the entire ice-free surface of Earth. Give you an idea of what that area is. It's greater than North America, South America, Europe, and Australia combined. You take the total area of those continents, and it adds up to slightly less than the current land footprint of animal agriculture, according to, among others, the International Livestock Research Institute, which is a livestock organization. And as you may have noticed, Earth isn't getting any bigger. And in fact, with global warming, the land surface of Earth is getting smaller. But the demand for meat is not getting smaller, it's growing rapidly. And in order to, because it's so land intensive, in order to meet that growing demand for meat, the only way to produce the extra land you need is by deforestation, primarily. And in the Amazon, for example, you hear about the rapid rate of deforestation. It's almost entirely due to the demand for meat, particularly beef. The very large majority of the deforested land is used essentially immediately to start grazing cattle. A small fraction of it, the next biggest fraction, is used to produce soybeans that are used domestically and exported from Brazil to feed pigs and chickens and cows. So when you see on your TV, smoke coming from the Amazon, that's the secondhand smoke from the steak you're eating. Okay. From a climate change standpoint, you can think of that vast land footprint as the opportunity cost of the global demand for meat. But the flip side of it is it's an opportunity to do something that nobody really even talks about in the climate science community, which is to actually turn back the clock on climate change. And the reason that's possible is that you can calculate, and there have been a number of publications that have attempted to do this, and they essentially all arrive at, within a very small fraction, the same answer. So let me illustrate this, though, with this nice picture. So this is a picture I took when I was on a hike in a place that Rachel knows well, I guess, which is Point Reyes, which is a beautiful natural park on a peninsula in Northern California. And this is a nice trail. This is my wife walking on a nice trail to a beautiful lagoon called Abbott's Lagoon. Okay, isn't that lovely? But the reason I took this picture was because you see a fence on the left side, okay? That fence demarcates the boundary between this protected national wilderness, actually, and a farm where beautiful Marin County grass-fed beef cattle are grazed, okay? This idyllic notion of, oh, it's grass-fed beef. Okay, this is your grass-fed beef in Marin County. And it's dramatic, and you can take a lot of pictures. In fact, Rachel was going to try to get me one from New Mexico, but didn't have time, of exactly this kind of juxtaposition where you have a boundary between essentially undisturbed, biodiverse land in its natural state and a farm where cattle are being grazed. And this is typical. And what it shows you is not only is there a vast reduction in both plant and animal biodiversity, but there's a huge difference in the total amount of standing biomass. And when you extrapolate that globally, the delta in biomass between the pre-agricultural and current state of land that's being used to raise animals for food is equivalent in carbon content to about 13 to 17 years worth of fossil fuel emissions at 2018 rate, which is roughly current rate. And that means that if you went the other direction, the recovery of biomass on that land through photosynthesis could actually capture CO2, and in fact, by some reasonable calculations, do so faster than we're emitting it, effectively turning back the clock on climate change and giving us basically an additional 15 years to figure out more definitive solutions to the problem. And of course, people who are in this business know that there are ways that you could actually do even better than getting back to baseline, but that can be a question. This is just to illustrate for the geeks in the audience, which might be the entire audience, something that a lot of people don't realize, which is this is the trajectory of atmospheric CO2 concentrations, which are one of the main measurement sites is in Mauna Loa Observatory. And you can see that the general trend is up and up and up and up. But there's also something else that's really important here, which is it's actually up and down and up and down because during spring and summer in the Northern Hemisphere, where most of the plant biomass and most photosynthesis happens, atmospheric CO2s drop precipitously, okay? This is just to illustrate what happens, how biomass accumulation by photosynthesis can actually bring down atmospheric CO2 concentrations relatively quickly. And what we're talking about here is when you have land that's being farmed or grazed, that big gain in the spring and summer is more than lost, in the rest of the year. So it basically is the proof of concept that this is something that actually works. Okay, this is the tell me a better solution if you have one, but I think this is the only credible way that we can halt and even turn back the clock on climate change, which we need to do. So anyway, blah, blah, blah. That was what got me into this, just realizing both the catastrophic impact of that technology and the real opportunity to fix it. So I founded Impossible Foods about 9 years ago with a simple mission that's been our mission since day one, which is to solve this environmental problem, restore biodiversity, and turn back the clock on climate change by completely replacing the use of animals as a food technology by 2035. And that time is critical because if the rate at which climate change and this collapse of biodiversity are progressing, we're going to be in a very dire state if we don't turn it around fast. So that's been the basis of Impossible Foods since day one. And here's our strategy. So one thing that I realized when I started working on this problem is don't waste your time trying to persuade people or legislate or compel people into reducing their consumption of meat. That is a complete losing proposition. China, actually, which is pretty good at getting its people to do what it asks, the Chinese government asked its people to reduce their meat and dairy consumption by half. This is about 3 years ago. And what happened? Nothing. There's no change in the demand for those foods. And that's just because it's common sense. People are so habituated and so much love the pleasure they get from their favorite foods that even if they care about these impacts, which are somewhat abstract and far away, it's just not motivating enough to give up something that you love. And that's been proven again and again. Okay, so how do you solve the problem? Well, there's a tried and true method, which is, this is a ridiculous technology. It's a ridiculous prehistoric technology. It's insanely, not only insanely destructive, but it's insanely inefficient from a economic standpoint. You're using the inputs which cost money and have value so inefficiently to produce food that you can sell. It's insanely inefficient in that way, and it hasn't fundamentally improved in thousands of years. But there's absolutely no reason why we can't develop better technology for this. This is what I realized as soon as I started thinking about it. And if we can do that, and what it means is not just making something that's an okay facsimile of meat and begging meat lovers to accept an inferior substitute. No, to do something that's actually completely doable, which is to make the best meat in the world, to make meat that outperforms meat from animals in not only in sustainability, but in deliciousness, nutritional value, and everything that matters to consumers. And to make it from cheap, abundant plant materials. So that was the thesis, and that I felt like if we do that and we compete in the market and we do it strategically enough, we will crash the economics of the incumbent industry and put them in the rear view mirror. So first thing I did when I founded, let me just get quickly to how we approach this scientifically, and then why I am so confident in our success, that we're going to succeed in our mission as stated. So when I founded the company, basically what I had realized is that, look, this is a really hard thing to do. We actually do not know how to make meat that is preferred by meat lovers to what we can make using animals. And I'm not talking about veggie burgers. It has to be something that actually consumers with free will choose over the current product. And so that meant we had to really understand what makes meat work. And that, when I found the company, in my mind, and still is, the most important scientific question in the world. Why? Because if you can answer that question and answer it in a way that points you the tools you need to make the best meat in the world, you can avert the biggest environmental threats our species has ever faced. So you can't get more important than that. So there's many aspects to what makes meat work, and you can ask me questions about it, but it's complicated. But I'm just gonna focus on one thing, because I think it's kind of a nice, vivid highlight and one of the most important things that we discovered. So you may have wondered what makes meat red, and a lot of people say, "Oh, blood makes meat red," which is actually not true, but close. What makes meat red or pink, if it's chicken or fish or something, is a molecule called myoglobin, not hemoglobin, myoglobin. Myoglobin is one of the most abundant proteins in animal muscle tissue. It's a protein that has the function of binding and transporting oxygen within muscle tissue. And it does so using, so this little squiggle of spaghetti basically is a representation of a protein molecule, which is basically just a long noodle of amino acids chained together that folds into a particular structure. And this is just a representation of that. But myoglobin is a heme protein, which means that wrapped in that squiggle of protein is a molecule called heme, an iron-containing molecule called heme, which is bright red, okay? And it's what makes your blood red and gives meat its red color. But there's another aspect, and I'll just add, heme is arguably one of the absolute most important molecules on Earth. It's literally essential for the survival of every living cell on Earth, from bacteria to fungi to plants to animals. It's an essential part of the system by which cells burn calories to produce energy. And obviously in humans, it's also essential for transporting oxygen. But anyway, what makes meat taste like meat? Well, we didn't know the answer to that question, although we sort of had a suspicion that it might also turn out to be heme for reasons that I could get into if you ask. But yes, it turns out that the heme in myoglobin is the critical ingredient that makes the flavor and aroma difference between meat as a category and plants as a category. Because fundamentally, most of the molecules in a plant cell and an animal cell are the small molecules that are relevant to flavor and flavor chemistry are very, very similar. They're amino acids and vitamins and sugars and fatty acids, but pretty much the same ones, whether you're a plant or an animal. But animal tissues have way, way, way more heme than plant tissues, hundreds to thousands of times more heme, which is basically because they burn more energy and consume more oxygen and so forth, okay, which is why they're red. So what we discovered, our R&D team discovered very early on, is that heme is the catalyst that makes meat taste like meat. And let me explain what that means. So if I were to take the juice from a plant cell or an animal cell, but leave out the heme, it's basically amino acids, vitamins, fatty acids, sugars, stuff like that, all the familiar biomolecules. And if you mix those all together and cook them, you get something that just tastes like kind of bland vegetable broth, okay? But if you just throw in a heme protein, bang, throw that in, it completely transforms. And that kind of blah tasting vegetable broth turns into intense, beefy flavor and aroma, okay? So heme is the magic ingredient for meat flavor. That's clear, as well as for the color, as well as for the transition in color when you cook meat, going from pink to brown. That's because the heme oxidizes. Anyway, okay. So now that's it for the science part. You can ask me questions, but now why am I so confident that we're going to succeed? Well, we have data. That's why. So the idea here was we need to make a product that, on an even playing field, beats meat from an animal in consumer preference. And we have actually test data that says in a blind taste test, not 100%, but more than 40% of current meat lovers, feted blindly in comparison to a cow version, choose ours over the cow version. And of the consumers that have ever bought our product, 90% of them are current meat eaters. They've eaten meat from an animal in the past month. So we're hitting the exact target consumer that we want. And we know also, we've done other kinds of experiments in the wild that basically show that a hardcore meat lover, if having tasted our product, once you tell them it's made from plants, now they prefer it to the cow version, because it turns out that people who love meat love the flavor, they love the aroma, they love the juiciness, they love the protein, they love the iron. But they don't love the fact that it's made from the corpse of an animal, actually. That's not a good thing for meat lovers, no matter how much they love meat. In fact, they love meat in spite of the way it's made. But if they knew it could be made from plants without compromising the things that they love about meat, then it's all upside, okay? You've eliminated the animal welfare issue that bugs them a bit. You've eliminated the major health issues with associated with meat eating, no cholesterol, lower saturated fat, et cetera. And all the environmental issues, which meat lovers increasingly care about. Not enough to change their diet, but enough to keep eating their diet, but have their meat made a better way. The other thing that we know that I think is a very strong signal about our future success is 70% of all these consumers, which are mostly meat lovers, who have ever eaten an Impossible Burger, more than 70%, have become repeat customers, have already become repeat customers. So that means it's just like kind of a positive feedback loop. Okay. now I want to show you some experimental evidence. And then
We have an A and B taste test. One is a real burger, one is an impossible burger. Can you tell the difference?
I want to go on record. I think B, just by the look of it, is the fake burger.
So A definitely tastes like meat.
All right, so now I'm going to try B. B is the fake burger.
Mm-hmm. I agree. If you just gave this to me fresh, and it was hot and fresh, I bet I wouldn't know.
I wouldn't know the difference.
And that's B?
Yeah.
That's B.
The reason you wouldn't know the difference is that is the real burger.
That is the real
You're
one.
kidding me.
Are you serious?
B is the real burger. A is the impossible burger.
That is insane.
That's amazing.
I'm shocked that both of you went with the wrong.
That is amazing.
That's wrong. That's wrong to do that to me.
I
That really
could go
is
vegan.
crazy.
I could go vegan. I am expecting my cows, because I have a ranch, cows, and that's what we raise them to be. I am expecting my cows to be taking their little hooves and pushing plates of this towards me. They're like, have you tried this?
The Impossible Whopper is right around the corner. 7,300 Burger Kings are about to have it as well. And they are going into grocery stores later this year.
If Glenn and I can't tell the difference, I think that's
incredible.
Wild endorsement.
I am blown away by that.
Yeah.
That's unreal.
We are anti-fake food.
Yes.
We are anti-vegan stuff. We both hate vegetables.
Yes.
And for that to fool, and I'm a rancher.
Yeah.
I'm a rancher. I breed my.
Okay. Anyway, so that was real experimental data right there. Okay, raw data, and I think what it shows is something that it's amusing to watch. I'm not a huge Glenn Beck fan, to be perfectly honest, but he's not going to do us any favor. He's not a fan of vegans or vegetables. But what it shows is something interesting, which is that people who love their meat and can't imagine life without it actually are not so addicted to having it be made from cows. Okay, that's not what they love. So I think that's more evidence for that. Okay, so just a couple more slides, and then I'm going to quit. So, people will often say, well, 2035, that's really soon. And that's a humongous, that's, multi-trillion dollar, trillion pound market. How do you ever get there? And people are so habituated, blah, 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 blah. But actually, history says when you have a better technology, and by better, I mean, it does a better job of giving consumers what they value from the particular function it serves, the change happens fast. It is not just a slow, steady process. It's basically, you reach a tipping point often very early and it's game over. This is an illustration from, more than 100 years ago. 100 years ago, things moved a lot slower because, for one thing, they were using horses. But even still, within a couple of decades, there was a complete flip from households depending on horses to not having horses and being completely dependent on cars. Another more recent example is cameras. So the first digital camera was actually introduced just about 20 years ago, and it was $1,000. It was 300,000 pixels. Total piece of crap from a performance standpoint, and it only stored 8 images. So, but in less than 10 years, Kodak was bankrupt, and you can just see in this curve, the red line is the introduction of digital camera, and then less than 10 years later, film is dead. Okay, better technology wins, and it reaches a tipping point fast. Okay, and that's it. So our approach is better technology. We believe it's completely possible to develop a better technology that not only is vastly more sustainable, but does a better job of delivering what consumers want than this ridiculous prehistoric artifact that we're using right now. So stay tuned. You'll see how it turns out. I'm done.
Thank you, Pat. Thanks, Pat. So everyone has a lot of questions here, by the way. Esther, thank you for answering a bunch of them. But let me ask you a couple, Pat, that one of them, we tend to get this quite a bit. How much biomass is needed to actually supplant cattle? And aren't you just changing one thing for another if you eliminate the cows? By the way, this question is from someone I know. This is not a plant. This is from Chick Keller, astrophysicist. We get this question quite a bit. So if you could answer it, it would be great.
I think that's a great question. And actually, when I first presented this to my department at Stanford, I gave a little research talk. This is before I started, but basically, here's what I'm going to do, blah, blah, blah. One of my colleagues, a brilliant scientist, a Nobel laureate for recombinant DNA and all that, asked that exact same question. He basically said, well, you know, you're just going to need to grow a lot more plants. But the problem is that that's a total misunderstanding of our agricultural system. So let me just give you a couple of factors, and we could go deeper if you want. The global soybean crop this year is grown on 0.8% of Earth's land area, compared to 45% for animal agriculture, 0.8% of Earth's land area. And it contains 50% more human usable protein than all the meat produced globally, okay, on 45% of Earth's land area. So the fact is that a very large fraction of the plant biomass, pretty much 100% of that corn, the part that's not turned into ethanol, and more than 90% of all the soybeans are only consumed by humans after they've been turned into a pig or a chicken or a cow. And the protein conversion ratio for a cow is more than 30 to 1, meaning 30 grams of protein to make 1 gram of cow protein, and so forth. So actually, you could produce, and just to give you another kind of perspective, all the plants that are directly consumed by humans, plus the soybean crop, which is mostly consumed by animals, and a lot of the crops that are consumed by animals, are grown on about 7.5% of Earth's land area, okay? So in fact, all the fruits and vegetables are grown on about 1% of Earth's land area. So no, you don't need more plant biomass. You need vastly less. In fact, one of the things that I think, you know, like a lot of soybean farmers, I love soybean farmers, but you know, are thinking, wow, this is going to be great for the soybean industry because you're using soybeans as a raw ingredient. Well, actually, we're going to need a lot less soybeans because we convert them with 1-to-1 protein conversion efficiency. And I think one of the consequences for the agricultural economy is that the land area required to support total global food demand, including all the meat, is going to be reduced from 50% of Earth's land area, when you count the vegetable crops, down to 7.5% of Earth's land area, meaning most agricultural land value will go to zero because you don't need it anymore. And that's a great thing because that means, okay, we can find other uses for it, like allowing it to accumulate biomass to capture carbon and restore habitat for biodiversity. Does that answer?
Yeah, that was great. Yeah, so got a lot of physicists on the line, I think. Another question is, you can make hamburger, but how do you make steak or a pork chop? Can you address, Pat, the whole cuts issue, and how hard is it?
Well, as any scientist will know, when you get a question, how hard is it to do something that you haven't yet done, you can't answer it until you've already done. Then you can say how hard it was. But we've done a lot of piloting. We've even made pilot, filet mignon and stuff like that. So we have a lot of, let's say, pilot experience that says, okay, this is doable. But of course, we don't want to just produce something that is a good facsimile of a steak, because that's not going to accomplish our mission. Our goal before we release a product is this is something that a steak lover would choose over the cow version, which is a high bar. But we're, we actually, we had been working a little bit on steak a number of years ago, we went all in on ground beef for strategic reasons, basically because I thought it's possible that if we do a good enough job on ground beef, it'll be sufficient to crash the economics of the beef industry, since it's more than half of all the beef produced in the U.S. So we put a lot of effort into that. But this year we're really ramping up the steak project, and we have a lot of clues to how to do it. But and I'm, let's just say, completely confident that we'll be able to launch one within a few years. But ask me technical questions about it, but basically that it has much more long-range structure. But we actually know a reasonable amount about how to convert plant proteins into sort of fibrous materials with long-range structure, and we've worked on adipose tissue, fat tissue and stuff like that. So we have pretty good reason to be confident, but we'll know when we get there.
Pat, you're getting a lot of questions basically about what's next. You've already got Impossible Burger and Impossible Sausage just hit the market. Charlie Doyle is asking, he is at the moment right now eating a slice of homemade pizza with Impossible Burger on it. Thank you. And he says, when will I be able to buy Impossible Pepperoni or other products?
I love that question. Well, actually, right now, the kind of crack pepperoni team at Impossible Foods is my daughter Ariel, who's made prototypes that I would say were very highly rated by chef tasters. I think Rachel might have been at that tasting, but we don't know how to produce that. We haven't gotten it to scale yet, so that's a work in progress. But yes, I'm super excited about pepperoni. I mean, every time when we talk to customers that are in the pizza business, they're basically saying, yeah, sausage, whatever. The topping that everybody really wants is pepperoni. So, we're on the case, let's say, and stay tuned. I mean, another thing that Rachel may have mentioned is that, we actually have a really good pork prototype. We gave samples to 2 Michelin star chefs in Hong Kong who who tested it in 5 Chinese dishes or 5 traditional Asian dishes. And basically what they told us was it was better than the pig version in every single one of those test cases. So trust me, stay tuned. Pork is a killer product, and it's coming your way at some point.
Okay, Pat, we've got a bunch of questions that fall into basically 2 categories. One is, what was the transition like from scientist to CEO? And then the other is, do you have advice for other people who are contemplating a similar move?
Well, my advice is, if you're contemplating a similar move because you're really, really motivated to solve a problem, that requires private enterprise or something like that, like us, my advice is go for it. And what was my experience like? I mean, a lot of people think it was like, oh, it's got, such a angst-filled experience, but it wasn't at all. I mean, I as soon as I realized that this was, the most urgent problem in the world, and nobody was seriously treating it as a solvable problem, I felt like, man, I'm all in on this. And I think a lot of scientists will identify with me that, when you're a scientist, basically, you just want to work on the hardest, the most challenging and important problem you can possibly work on that you think you have a chance of solving. And the rest is details. And the CEO part really, for me, there's actually there's interesting things that there's problem solving. That's not unlike problem solving in basic science, different in details, but that it involves, modeling, creating models from your ideas and testing them, and and even just, thinking strategically about how to solve problems and so forth. So it wasn't at all alien to me. I have zero interest in the financial part, but basically when I started the company, I hired a bunch of super good people, to manage the finances and to manage the HR and the business operations and stuff like that, because I had zero interest in that, and I wouldn't have been good at it. And I just focused on, strategy and communication and basically the R&D stuff, so don't be afraid of doing it. I mean, basically, you want to just do the most important thing you can with your life, right? And if you see a challenging problem that can have a big impact, man, just go for it.
Okay, question from Richard Sayer, who I personally also know, an early adopter who bought the first Tesla in Los Alamos County. I used to work there, for those who don't know.
Did you get a commission for that, Rachel?
No, I did not. Impossible Foods products contain ingredients from recombinant yeast. How are you able to convince the consumer that GMO foods are safe?
Oh, yeah, that's an interesting question that comes up a lot. I think but it turns out that it has been much less of an issue than a lot of people imagine. So there are a very, very tiny minority of consumers that are just diehard anti-GMO, highly correlated with being anti-vaccine and pretty much anti-science in general, and that are not interested in having a conversation and listening. But the vast majority of consumers, if we're just transparent about it, we were from, long before we had a product in the market, we were very public about the fact that this is how we're going to be at scale producing our most important ingredient. Here's how we're doing it. Here's what it entails. Here's why, et cetera, et cetera. And if you just take the time to explain to consumers why you're making this choice, why, it's actually a better choice in almost every way for the environment, for their health, and so forth, they're completely satisfied. I mean, the fact is most consumers don't spend a lot of time thinking about this issue, and frankly don't understand it all that well. And the noise you hear about is just that it just seems spooky and I don't understand it, and why would you do this and stuff like that. And the only way the easy way to solve that problem is just take a few minutes to just talk them through it and explain it. And they realize, oh, okay, no big deal. Aside from the fact that, the majority of all the cheese that they're eating right now is made using a plant-based, using a rennet that is produced by inserting a cow gene into the yeast genome and producing it by fermentation and so forth. And many, 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 many other components of foods that people eat every day are produced that way, and nobody's freaking out about it. So, I mean, there's a handful of people freaking out about it, but they don't, not
great. Okay. Lot of people asking questions around nutrition. I will read the one from, let's see, Sharon, or let's see, there's a couple on this one. Yeah, what plants do you use? How natural are the plants you use? And are they just processed to make it taste good? Says Sharon. We don't want to exchange we don't want to exchange what we use now to use more chemically processed foods. So tell us, Pat, how natural are the plants you use, and are they just processed to make it taste good?
Okay, well that's so first of all, the plants we use are by and large simple, familiar plants. The major proteins come from soybean and coconut. The major fat comes from coconut. The other major protein comes from potato. The only protein that's produced not from a plant, but by yeast is our heme protein. And then the other ingredients also just come from basically, they're not synthetic. They're not produced by synthetic chemistry. And then processing. Okay, actually, that's a very long topic, but most of the foods that you eat, whether you go to a just a restaurant that sources local plant ingredients or anywhere else involve a lot of processing. I mean, to make a loaf of whole wheat bread, in fact, my wife was just telling me she was working on something about processing that a loaf of whole wheat bread at Whole Foods contains more ingredients than the Impossible Burger. It's throughout history, the foods that we eat have been based on people exploring potential food sources, figuring out which ones are safety, which ones are healthy, which ones are delicious, figuring out how to process them to make them safe. If you eat raw beans, they will generally make you very sick because they have anti-nutritive factors and some factors that are even kind of, in a way, directly toxic. So if you don't cook them, they're not edible. Cassava, one of the most widely consumed crops in the world, and particularly the tropical world, is toxic if you don't process it. You have to process it by grinding it up and soaking it with many washes of water. And there's many, many, many foods that are unhealthy and unnutritive without processing. And historically, we've figured out how to take ingredients from many sources and combine them and treat them in ways that make something delicious and healthy and more than the sum of the parts. So processing gets a bad name. And it gets a bad name because when you think about processed foods as a category, you think about Fruit Loops and all these foods where the goal of the producer is to make them as profitable as possible with essentially zero concern about their health and nutrition value. We are not that company. We are not ever going to produce a product that we don't believe, based on all the research that we can access, is healthier for the consumer than what it replaces. And like I said, I mean, go to a fancy restaurant and the food that you get served is the result of a lot of processing by the chef who has made very deliberate choices of healthy, delicious ingredients and found a way to process and combine them to make something you want to eat.
Well, we just have time for one or two more questions, and you're still getting a lot, but a couple of questions have come in around this, so I'll just read one. We've heard many outbreaks of COVID-19 in slaughterhouses and meat processing plants. What's the reason for this, and how does plant-based meat processing, how is it different, and does it avoid these outbreaks?
Okay, yeah, well, why are there outbreaks in slaughterhouses? I mean, I'm not the expert on it, but I can say in a nutshell, based on what I know about, is that, slaughterhouses were not optimized for the well-being of the workers, and certainly not for the well-being of the animals that enter the door alive. So they involve workers who are crowded together, doing brutal, hard work, shoulder to shoulder, basically everything from stunning and killing an animal to putting it on a hook to successfully eviscerating it, chopping it into bits. Very hard manual labor that requires groups of people, working in close proximity. That's how the place was designed. And it is virtually impossible to have effective social distancing under those circumstances. And so it's, that's the reason why these places are just perfect incubation grounds for COVID epidemics and continue to be. How are we different from that? Well, basically, we have a completely different process. First of all, it doesn't involve some pathetic animals trudging their way into a place to meet their demise, covered with their own feces. But it's our process. Basically, the workers in our plant, by and large, are not doing brutal manual work. They're operating equipment that does all the heavy lifting and all the work. basic centerpiece of our process is like a giant mixing bowl on steroids, you could say, where we just put the ingredients in there and it just get mixed around, and that turns all the ingredients into our ground beef product, which we then form into stuff. But it's all mechanized, automated equipment that's doing the heavy lifting, and the workers are primarily just operating the equipment. And that just enables that. It makes it much easier for us to enforce social distancing. Since the epidemic happened, we've instituted. We've raised the bar on sanitation. We do daily deep sanitation. We require all our employees to wear masks and face shields, and we have heavily enforced hygiene requirements and so forth. We've had 0 of our employees come down with COVID so far, and can't guarantee it won't happen, but to the extent that we can prevent it, and so far we've succeeded, it won't.
Okay, thank you. Like I said, we're getting still a bunch of questions, but we definitely wanted to make sure that we kept this for 1 hour. So I'm going to end it right there. But thank you, everybody, for coming. Thank you, Lauren, for hosting this, and to Peak for doing this. We really look forward to it, and to some point in the future, in the post-COVID world, when we can actually get Pat to come to Los Alamos to talk to everybody in person.
Please do invite me. I'll definitely want to come. And thank you all for taking the time to listen to me and for the great questions. And maybe if they're in the chat stream, we can offline. I don't know whether do we know how to contact people? Well, we can figure out a way to answer them offline and so forth. I'm sorry we didn't get to all the questions, but hopefully we got some good ones.
Thank you so much, everyone. And thank you, Esther, answering 20 questions during this show. So thanks, everybody. Thank you, Lauren. I don't know if you have any closing comments, Lauren?
Thank you so much, Pat and Rachel, for hosting and joining us. People can tune in to our ScienceFest app, and we can possibly get some more questions answered there too. So I'll pull the questions here that weren't answered, but thank you everybody for attending, and thank you again, Pat and Rachel.
Thanks, everyone.